Though it may not look like it at first, this sourdough starter is teeming with microbacteria. Though some might think this is a bad thing, it's actually what gives San Francisco sourdough dough its taste and texture. While there are likely several types of organisms in this dough, albeit in minor quantities, there are two main microbacterium present in this starter. One of these is Lactobacillus sanfranciscensis, a major part of the lactic acid bacteria group. It is named after San Francisco, where sourdough was found to contain the variety, though it is not endemic to the area. They convert sugars into lactic acid. Another ingredient found in this dough is yeast, the most common of which is Candida humilis. Though present in much smaller quantities than the lactobacillus, this humble bacteria is still essential to the bread making process. The two microorganic species work symbiotically in the bread by consuming sugars and emitting various substances. The lactic acid bacteria metabolize sugars that the yeast cannot, while the yeast metabolizes the byproducts of the lactic acid fermentation. The yeast takes the sugar and produces carbon dioxide gas, which leavens the dough and makes it rise, while the lactic acid bacteria produces lactic acid, which makes the bread so sour. Both of these organisms use fermentation to produce energy, creating lactic acid and hydrogen and alcohol, respectively. In microorganisms, fermentation is the primary means of producing ATP by the degradation of organic nutrients anaerobically. Basically, microorganisms require fermentation in order to survive. They need the energy produced in the form of ATP in order to live and reproduce. During fermentations, cells convert NADH to NAD+ by passing high-energy electrons back to pyruvic acid. This action converts NADH back into the electron carrier NAD+, allowing glycolysis to continue producing a steady supply of ATP. Because fermentation does not require oxygen, it is said to be anaerobic. Lactic acid bacteria and yeast are aerotolerant anaerobes, which means that though they are anaerobes, they can multiply in the presence of oxygen. This is necessary because in the dough they don't have a consistent supply of oxygen, and yet they are exposed to it many times. Other organisms, like humans, are anaerobic respirators, meaning that they require oxygen to survive. A major argument in favor of aerobic over anaerobic respiration is overall energy production. Without oxygen, organisms can only use fermentation to produce two net ATPs. In anaerobic respiration, this is where ATP production stops. There is a final total of only two ATPs produced per molecule of glucose. This anaerobic process does occur very quickly, though. Aerobic respiration, on the other hand, produces ATP more slowly. It does, however, break glucose all the way down to CO2, producing up to 38 ATPs. While this may vary slightly, aerobic respiration consistently produces 15 times as much ATP as anaerobic respiration.
Jack worked really hard on this project. I was pretty amazed that he got up every morning and fed the bread. It was really taught me a lot, actually, quite honestly. I think he was diligent and worked hard.
Pretty good.